Hi and welcome to this technical description of the updates to the T24 radio system. I'd like to take a few minutes today to give you a bit of a description of the updates that we've made to the T24 wireless telemetry system. My name is Clive Vance and I'm an electronics design engineer with Mantracore Electronics. The T24 wireless telemetry system is used to send and receive data. It's a license-free radio working at 2.4 gigahertz. It can connect to a multitude of sensors, and we reduce the cost of installation by removing the wired component. Now, recently we've made some updates to our hardware, and we've focused on the redevelopment of the RF front end and the antenna, and that's what I'd like to talk to you about today. I'd like to start by talking to you about the changes that we've made to the RF front end. So we've increased the transmit power and we've improved the receive sensitivity. Now, the main thing that you can really take from that is we've added about 20 dBs to your link budget, and in real terms that constitutes a four-fold increase in the range of product in any given application. The next aspect that we focused on was the antenna. So we've redesigned the antenna to be a planar inverted F antenna. We designed it to have a wider bandwidth, and we've designed it to be more omnidirectional. Now, you can kind of think of the omnidirectionality as a bit like putting a light bulb in the middle of a room. It shines in all directions, as opposed to basically having a torch which kind of lights up one side of the room and not the other. But the main points that I wanted to bring to your attention with regards to the antenna are easy to demonstrate on a network analyzer. There are two main things that you really need to kind of focus on with a network analyzer when you're looking at an antenna. That's how deep this kind of trough is. Like the further down the screen the traces sit, the better the match. Also, the more the antenna moves around, so you can see that the yellow trace is moving around just with my hand being nearby. And what that tells you is that it's closely coupled to the environment around it. And that's what you really want from an antenna. That's what tells you that it's actually radiating and getting the energy that you put into it out into its surroundings. Now, the big thing with antennas is what happens when you put them near other objects. So you can see here, if I move the antenna and move it close to a metallic object, it moves around a lot. But the big thing is that the match still stays really good. So you can see that we're very close to the shackle here, and the match is very good. Now, what I can also show you is this reference dipole antenna. So this is a 2.4 gig dipole antenna, and again you can see that in some certain circumstances it does actually stay pretty good, but you can see that I'm in a similar kind of position to where I was with the antenna, and you can see that actually the match has actually worsened slightly. Still reasonably good, but it's worsened slightly. So one of the main things we wanted to do was to keep a good match when it was near to metallic objects. So the changes that we've made to the platform improve the usage in all scenarios. Specifically, the orientation is a great improvement because it means you don't need to be quite so focused upon your transmitter and the orientation that it's in order to achieve the best RSSI level. Specific applications like non-static positioning of sensors, so anywhere that the sensor can move relative to the receiver, we'll see a great improvement. Thank you for your attention, and I hope that you found the information in this video useful. If you want any more information, please find the details on mantracore.com.